So guys, welcome to this live session. So we want to be doing some simple arithmetics. So feel free to join. Leave a comment. And most importantly, subscribe. Subscribe. So we have a problem of maximum and minimum, which combines quadratics and a bit of calculus. We are being told that given that x plus y is equals to 60, find the values of x and y, which will give us the maximum product. So guys, on the solution, part, I'm going to write some two equations here. I know that the sum x plus y equals to 60. And then I'm being told the product. For me to get the product, I'll multiply the two values. So in this relationship, I'm going to make x or y the subject in this particular equation. So if I decide to make x the subject, 60 minus y, so I'll substitute 60 minus y in this Roman 1 equation, so that the product now becomes, I'll replace it here. So my product now becomes 60 minus y multiplied by y . So now, of course, if you multiply now, the product is going to be 60y minus y squared at maximum. I know that the derivative of my product should be equals to 0. So this is my product. So if I try differentiating it, I will have 60 minus 2y is equals to 0. So this tells me that 60 is equals to 2y So y is 30. X plus 30 is equals to 60. Then it goes that x is also 30. So that means that So guys, remember to subscribe. Leave a comment. Leave a comment. So you've been given another equation here, and you've also been given your solve by matrix method. So problem like this, first step, I'll separate the variables from the constants or the coefficients, and I'll write as a matrix form. So the coefficient of x is 2, the coefficient of y is 1, then that is 2 and 2. Take the variables on the other side, write it as a column matrix, should be equals to 10 and 14. Also write it as a column matrix. So I know this problem is very easy to do. You can try it out. I'm going to use the inverse. So find the inverse of this matrix by starting by the determinant. So the determinant, I'll take 2 by 2, subtract 2 minus 2 by 1. So that means it is 4 minus 2. Of course, my determinant is 2. So next, I'll take inverse of the determinant, multiply by the matrix, but now I interchange this sign, the signs changes. So this is my inverse. Which I can simplify it as opening by a half, and I get 1 negative a half, negative 1, 1. So pre-multiply. Next step, I'll pre-multiply by matrix inverse. I'll pre-multiply by the matrix inverse on both sides. So I've pre-multiplied by the inverse matrix on both sides. Next step, if you multiply an inverse and the matrix, multiplying them together, of course, I'm going to have an identity matrix. So pre-multiplying this and this, of course, I'm going to get an identity matrix 1, 0, 0, 1 for this side. I have xy. And on my right hand side, pre-multiplying this and this, using row by column, I'll have 1 times 10 So we're going to get the answer as 3 and 4 in terms of column matrix. Then it goes without saying that our answer x is equals to 3 and y is equals to 4, which are the solutions for our problem here. Got x 3, put here 3, 2 times 3 is 6, 6 plus 4 is 10. So which is correct? So guys, keep subscribing, keep subscribing, keep subscribing. So we are through with the matrix problem of the equation. You're being told to differentiate the log of exponential x squared plus 3x plus 1, then with respect to x. So guys, if you ask to differentiate this particular problem, then you're going to apply chain rule. Chain rule. So guys, subscribe, leave a comment. So applying chain rule, I know that chain rule says that if I have derivative of y with respect to x, this is the same as applying derivative of y with respect to du dx dot dy to du. So I'm gonna change or let what is inside the bracket to be u. So let u be x squared plus 3x plus 1. So remember to subscribe, guys, please, so that now my equation now changes to log of exponential u. Next step, derivative of logarithm expression. If I differentiate, remember this was my y now. So differentiating this with respect to u, dy du, then of course I'm gonna have 1 over u if you differentiate a logarithm expression, so of course, if I differentiate this, I get this. While if I differentiate u with respect to x, remember my u is this one. So differentiating it again, I'm gonna have 2x plus 3. So guys, leave a comment. Remember to subscribe guys. So I have dy du, and then I have du dx. Replacing them in this relation or chain rule, then of course I'm gonna have 1 over u multiplied by 2x plus 3, 2x plus 3, which of course if you substitute u as this one, then now my equation gonna change to 2x plus 3 over x squared plus 3x plus 1, which is actually the solution to our logarithmic function where we're required to differentiate. So guys, keep on subscribing. Don't leave without subscribing. Leave a comment. So the next thing, I want to differentiate a trigonometric function. So you want to derive trigonometric function. Derive trigonometric function. So you're being told to differentiate tan x with respect to x. If you're asked to differentiate tan x with respect to x, then the steps. So on the solution part, I know that tan x can be written as sin x over cos x. So instead of differentiating tan x, I'll differentiate sin x over cos x. And then, so I'll use quotient rule. I'm going to use quotient rule here. So I'll differentiate sin x over cos x. But the quotient rule says that if I have a function f of x, then and f of x is maybe u over v, So somebody is saying my video is not clear. So if you have two functions, one is in the numerator and one is in the denominator, then the quotient rule is saying I'll take v multiplied by the derivative of u minus u multiplied the derivative of v and then over v squared. Of course, that is what I'm going to apply here. So I know my u is sin x and my v is cos x. My u is sin x. My v now is cosine of x. So guys, remember to subscribe, please. So replacing it in this function of x, then it's gonna be the cos of x, that is my v, multiplied by the sine derivative of sine of x, derivative of sine of x. I'll subtract on the other side, my u is sine of x multiplied by the derivative of cos x, everything over cosine of x squared. So when I do that, I'm gonna have, if you differentiate sin x, of course you're gonna get sin x, you get cos x minus I have sine x multiplied by derivative of cos x. Of course, you get negative of sine x so this is negative and this is negative. Then of course I'll have the cos squared of x. If you take negative and negative, remember this one was like this. Opening the bracket, you're gonna have positive sine squared x, sine squared x So, but of course, in the denominator, I have the cos squared of x. So let me transfer it here. So I have cos squared x plus sine squared x over cos squared x. So you can recall that the cos squared of x plus sine squared x is equals to 1. So then it means this equation now changes to 1 over the cos squared of x. This equation now changes to cos squared of x. And of course, what is cos squared x? Cos squared x can also be written as the sec squared x, or it can also be denoted as 1 plus the tan squared x which of course is the solution for our function here. We are required to differentiate what is tan x, and step by step I've taken you through up to the end. So guys, don't forget to subscribe, like, and you can even share. So another one here, we are being told to simplify, solve for x and y, given that I have 4 raised to power 4x, and then I have 2 raised to power negative 2y is equals to 64. So this is an index equation under indices. So on the solution part, I'm being required to find the value of x, which when I substitute here, and the value of y when I substitute here, it's gonna give me 64. So the first thing, look at 64. 64, I'll separate it by writing it into factors, which I can express into base 2. So on this side, I'll have 2 raised to 2 for x multiplied by 2 raised to negative of 2y should be equals to 64 can be written as what? Can I write it as 16 times 4? 16 times 4. Then of course I can separate this one into base 2. Let me see. So 2 raised to power 8x times 2 raised to power negative 2y should be equals to, of course, this is a positive number, so this is bigger. multiplying a number by a negative will make it smaller. So that means writing this one can be 2 power 4 multiplied by 2 power 2. Then it goes without saying that this is positive and it is bigger compared to this one. So that means I'll compare or I'll equate this function to that function. But of course, multiplying the product of the two should give me so doing that swiftly, I'm gonna have 2 raised to 8x should now be equals to 2 raised to 4, since I've taken it as a positive and it is bigger, of course. 2 raised to power 4 is bigger than 2 raised to 2. So dropping the bases, I'll have 8 raised to x is equals to 4. And of course, x now becomes a half. You've seen it? While y now, I'd equate this to this as 2 raised to power negative 2y is equals to hi joyous cakes. You're welcome. So I've taken 2 raised to power negative 2y is the same as, or equated it to 2 raised to 2. You can drop the bases and equate the powers. 2 negative 2y is equals to 2. So guys, remember to subscribe, leave a comment. Hi Joyous, I'm glad you're watching. So guys, divide by negative of 2y, negative of 2y. Then of course, y now becomes negative of 1. Like. Don't forget to like. Don't forget to like. So we can prove again, if possible. If you take x as a half, so 4 raised to power 4, but now my x is now a half, but my y is negative 1. So you can prove if it is giving us 64 from this equation. So then